Welcome to Oilfield Academy, your source for smart, practical oilfield skills. Let's power up your knowledge.
Welcome to our third session. And the first two sessions, we have introduced the introduction to our course. And as a second session, we have discussed the injector head components, injector head session part 1 on the session 2, the injector head components, traction system, tension system. And today, on the third session, we will discuss the remaining of the injector head components, weight indicator system, and depth counter. Let's start with the accumulator system.
There is which is called accumulator. The accumulator, it's located on the bottom of the injector. If we take this portion here, these cylinders are the accumulator. The cylinders here are the accumulators. What are the accumulators? The accumulators we will talk in detail in the hydraulic circuits, but to imagine the operation, the hydraulic circuit need a stabilization or shock absorbing to be steady pressure in the hydraulic system. We need a steady pressure. So this is pre-charged cylinders are used. This is pre-charged cylinders are used as shock absorbers when we are dealing with any fluctuation on the hydraulic circuit. So these cylinders will be as a choke absorbers. If we see the traction system and the accumulators on the field, if we imagine here, what is this? This is the gripper blocks, as we will see on the next slide. This is the accumulators. Accumulators are connected, as we see, with this hydraulic hoses. The hydraulic hoses are coming out from the especially for the traction system, are coming from the priority circuit. This is the hydraulic pistons for the traction system, as we see, the upper and the middle and the lower traction system pistons. These pistons are exerting, as we said, the axial force to make the required gripping force for my pipe through the chains and the gripper blocks. This is the gripper block. The gripper block is, as we will see, the gripping elements attached to the chains to not make a bite or a damage for the coil tubing. The chains are connected to this gripper blocks to grip my pipe. Okay, the gripper blocks, as we saw in the video, gripper blocks here on the outside diameter of the chains. So if the rotation completed, the gripper block will grip the pipe. And from the other side, we said we have two sets of chains, two drive sprockets, two chain sprockets, two idle sprockets, and two sets of chains to complete our cycle to grip the coil tubing pipe between them. So the gripper blocks or the gripper element blocks, it's if we imagine this is the shape of each element, it's connected to the chains from the either side, as we saw on the video, the either side of the chains, and the pipe will lie where will lie on this middle of the gripper block. Gripper blocks here on the outside diameter of the chains. So if the rotation completed, the gripper block will grip the pipe. Okay, the gripper blocks can be of different types. The most common types are the V gripper block. The V gripper block can accommodate different sizes of the coil tubing, but on the semicircular gripper block, it accommodates a single size of coil tubing. So in the V, as we will see here, the V gripper block, it can accommodate different sizes of the coil tubing, but it exerts more forces because this contact area of the gripper block with the coil tubing pipe on those 2 points only. But in semicircular, the force are divided on the whole section of the pipe. But it has its advantage to accommodate different sizes, so it will save my time and cost of operation not to use or to dismantle the chains and change the gripper blocks if I want to change my coil tubing size. The gripper block designs, the most common design, this design, S-type. What is the S-type? As we see, this is the skid plates, and the chains itself have its ruler bearings, and then lies between these chains the gripper blocks. As we see, the gripper blocks will hold or grip my coil tubing pipe. So in the other design, the rulers are in the skids itself. So in this S type, which is called solid bar skid, solid without rulers, solid for S. The rulers on the chains itself, but on the ruler skates, the rulers on the skates itself, and the chains without rulers, then the gripper block. But the most commonly used is the S type, in which we have a solid skates and the rulers lies in the chains itself. We will talk briefly about the gooseneck. The gooseneck have some rulers here. These rulers will take my coil tubing pipe to allow the entry of the pipe. This smooth entry allows that the coil tubing have no abrasive bending, because if imagine we are leaving the reel and we need to change the direction, so the smooth change of direction of the coil tubing will lowering my bending stresses on the coil tubing itself. So in the design of the coil tubing operation, we select our guide arc radius depending on the size of the coil tubing itself. As we said, if we have 2-inch pipe, another size 2-inch pipe, so we will see that the range I can use of the tubing guide arc will be higher than 1.5 inch. We have 2-inch, we may need 2 times 40. 40, it equals 80, so we may need 80 inch radius of tubing. If we regain or recap the components here, it was a hydraulic drive, brake system, drive chain and tensioners, goes neck or guide arc, and this is we have talked about. So there is a small components or functions we can talk about now. The weight indicator sensor, and the depth system sensor. Okay. For weight indicator sensor, it's fixed. The weight indicator system, it's fixed at the bottom of the injector, the bottom part of the injector. Okay, it's at the bottom part of the here. This weight indicator here, the weight indicator sensors are like diaphragms are affected by the weight of the coil tubing pipe. The coil tubing pipe weight are affecting on what, or affecting on the injector frame itself. And the injector frame we're rested where? We're rested on that 2 points. On that 2 points, we will fix our or install our weight indicator sensors. So by means of the weight of the coil tubing, it will affect those sensors, and from the readings, it's like diaphragms, and the output signals of from this strain gauge or from this sensors are converted to the weight of the coil tubing pipe. Okay. In a hint, in our operation, as we will see after that, we have which is called a positive or negative weight. What is the logic of the negative weight or the negative forces? It will be discussed later, but for now, the coil tubing weight is not affected by the weight of the coil tubing itself only, but affected by means of factors. like stripper pressure or stripper friction, like downhole friction, like drag forces, the hydrostatic head, the wellhead pressure. So the resultant force of those all forces, which is called the tubing load or the surface weight. The surface weight which are reading here by this means of weight indicator. So if those forces, the resultant force are negative, because we will see the equations after that, because we subtract from the coiled tubing pipe some terms. So these terms, if are large, higher than the coiled tubing weight, especially at the surface. The coiled tubing weight at the surface is the minimum weight. So another factors will may be exceeding the coiled tubing weight, make the resultant force is negative. Let's talk about the injector specification. What the injector can do. The injector can do what is the maximum pulling force, what is the maximum snubbing force, the pulling force, the snubbing force, and the traction can exert on the pipe, and the speed it gives. So the maximum pulling force, the maximum snubbing force, the maximum traction, and the maximum speed are the specification or to select my injector and required for the corresponding coiled tubing application. The maximum pulling force, by the way, it gives the name of the injector itself. The number are attached, are included on the name of the injector. It reflected the pulling force or the maximum pulling force. Okay, the maximum pulling force, it's the maximum tensile force the coiled tubing can apply, and the snubbing force is the maximum compressive force or compression force the coiled tubing can apply. Snubbing means the compression or the coiled tubing weight I put on it to go down. But the pulling, the weight I put on it to go up. The maximum traction exerted by the axial force by means of traction system, and the maximum speed, which is controlled by the motor of the injector head. As we see here, the depth counter, as we said, this is dials of the mechanical depth counter. This is the by means of rotating sheaves. This is small sheaves are mechanically touching the coiled tubing itself. So by go down or up, this is rotated sheaves are give the reading here for the depth during run hole or pull out of hole. And at the bottom of here, this is the connection for what is the coming next down to the injector, which is the stripper. Okay, so this is the stripper mount or the stripper connection to be connected to the stripper down the injector. As we said, this is the injector specification, the maximum tube pulling force, as we will see here. We will select, by the way, any other depending on the application. As we said, this is the name 80 means the pulling force will be maximum pulling force will 80,000 pound, and the other specification, as we said, the snubbing force, the running speed, and the dimension, of course, to fit on our location. So this is a criteria of selection depending on the application and the calculation, especially calculated by the software designed to select our coiled tubing forces and corresponding injector heads. Different types of injector head ranging from, as we said, different pulling forces, 30K, 80K, and there is 60K, and up to 100 and exceeding 100K in some design.
On the next session, inshallah, we will discuss the coiled tubing reel.
Thanks for watching. Please don't hesitate to contact through any platform for any inquiries or questions. See you next session. Bye bye.